Today we're going to look at some line plots. Now, we will be learning how to make line plots and how to read or interpret line plots. We're going to begin with learning how to read or interpret these line plots. So, first of all, what is a line plot? A line plot Line plots are used to show the frequency that something occurs. And it uses x's. So it's going to show the frequency that something occurs by displaying data or information on a number line. So this word frequency, that means how often something occurs, how common it is. Now, when I draw this, it might look familiar to you because I know that in other grades, you've learned how to show information on a line plot. Maybe you made a chart about your favorite color or your favorite pet, but this time we're using numbers. So it all begins with a number line. Here's my number line. It's going to start at 0, and I'm going to measure it off in fourths. So 1/4. 2/4 would be the same as 1/2. Then I have 3/4, 1 whole, 1 and 1/4. 1 and 2/4 would be the same as 1.5. And we're going to mark 1 and 3/4. So, all good charts need a title. If you're going to make a graph or show data, you need to be able to figure out what that graph or that chart is telling you. So we're going to name this one Cups of Sugar in Recipes. All right, so we are going to make a chart that shows cups of sugar in recipes. Now, we know that so far we've done two things. We've made a number line, and on that number line, we have units. These units are the fractions. So, what do these fractions represent? Each of these fractions shows the amount of sugar used. So this would be 1/4 cup. This would be 3/4 cup, 1 1/4 cup, 1 1/2 cups, 1 3/4 cups. So each fraction shows the amount of sugar used. We know that it's sugar because we have a title. This is our title. So our title shows what the numbers, and I'm going to use an abbreviation for numbers. I'm going to use the number symbol. You all might know it as the hashtag symbol. So it shows what the numbers represent. All right, so how are we going to show all these different amounts? So let's say that you're a chef and you're trying to figure out how many different amounts of sugar you need in recipes. So we're going to pretend you're going through all your recipes and you pull them all out and you're making a list. Hi, Millie. I'm so sorry, you all. And you start listing them off. So we're going to say Millie's helping me make my list of amounts of sugar in a recipe. And she's going to call out certain amounts. So she's going to call out, oh, this one needs 1/4 a cup. Okay. So I'm going to come in here and I'm going to put an X over 1/4 a cup. This one needs 1 1/4 cups. Oh, okay. And you go to the next recipe, and that recipe calls for 3/4 a cup. Okay. And then the next recipe you get to calls for 1 cup. Okay. And oh, here's another one that says 1 cup. And you go through all your recipes. Now you're finished with your recipes. When you've looked at this, you've gone through and for each recipe marked how much sugar it needed. So each of those X's represents something very important. Each X represents one recipe. This is where it gets confusing. Line plots can be really, really tricky, but they're only tricky if you don't understand what they're showing. If you're in my class, you know that all the time I tell you that everything is a pattern. If you don't understand the pattern, it's not going to make sense to you. As soon as you understand, then it'll click and it will make sense. This is where it gets confusing if you're not paying attention. Each X is a different recipe. The X does not stand for the amount. So in all, I looked at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I looked at 16 recipes. Not 16 cups of sugar, but 16 recipes. Each X stands for a different recipe. And I can use this to answer questions. So I might think, how many of my recipes call for 1 cup of sugar? Well, I can come along here to the bottom of my chart and go, oh, here's 1 cup. Well, let me count. 1, 2, 3, 4, 5. 5 recipes call for 1 cup of sugar. So let's look at a different line plot. And we're going to use this line plot to answer some questions. Are you ready? Okay. Here we have our line plot. And it's labeled in inches. Notice that we know that it's labeled in inches. We have 0, 1, 2, 3, 4, 5. What do you think these marks in the middle are going to represent? They're going to be fractions. So right in between 0 and 1, we're going to have 1/2. And I'm going to mark those for you. Let's pull out my black pen. So 1/2. Right in between 1 and 2, it's going to be 1.5. In between 2 and 3, we're going to have 2.5. And that's going to continue on because everything is a pattern. Okay, now that I have it all labeled, I'm going to look and I'm going to see that it's called amount of rainfall per month last year. And this line plot has even told me that every X equals 1 month. So each X is a different month. As they went through and marked all their data, every month they measured the rainfall, and wherever it landed, they put an X above that amount. So let's look and see if we can solve some of these. All right. The first question says, what was the difference in the amount of rainfall between the month with the most rain and the month with the least rain? So, I'm going to have to think about this. I'm looking at the difference in. If I'm trying to figure out the difference in numbers, I know that I'm going to subtract. So right above that word, I'm going to put a little subtraction symbol just to remind myself. And I'm going to be looking for the month with the most rain and the month with the least rain. Most means the biggest amount. So I'm going to look to see the biggest number I have. Nothing was marked with 5. But did we have anything with 4.5? Yeah. So the month with the most rain, well, that would be 4.5. So let me write that down. 4.5. The difference in, so I know that I'm subtracting. And then the month with the least rain. Well, the smallest number is 0. There's nothing there. And we have half, but there's also nothing there. Oh, 1. So we have a 1. Okay, so 4.5 minus 1. Well, if I have 4.5 holes and I take one entire hole away, I have 3.5 holes left. So the difference in the amount of rainfall is 3.5, and I have to remember my units. What am I measuring in? Inches. 3.5 inches. That's it. Now the next one. What was the total rainfall during the 4 months. So total, if I'm finding the total, I'm putting it all together. And when I put things all together, I'm adding. So the total rainfall during the 4 months that received the least amount of rain. Least means the smallest amount. So I'm going to come to the very small end, and I need to look at the 4 months. Okay, so let's see. Nothing, nothing. Oh, 1, 2, 3, 4. So I'm looking at these amounts, the total rainfall. So my 4 amounts. One had 1, and then we had 1.5, 1.5, 1.5. Now you need to know something. There are many ways that you can solve this. You are welcome to add it up normally. You are welcome to put it in a calculator. If we were to add this up normally, here's what I would do. Since I'm adding, I know that I can break this apart. And I'm going to begin by putting together my fractions. So I see that I have a half, and a half, and a half. Well, I know that I can put those two together to make a whole. So now I have 1, 2, 3, 4. I've put these halves together to make 5. 5 wholes. And then this half is still there. Very nice. But there's another way you can do this. If I look at my chart, I see that there's 1x above the 1. So for 1 inch, we only have 1. How many x's, how many months have 1.5 inches? 3. So for 1.5 inches, there are 3 months. So I can multiply. Because when we use repeated addition, 1/2 plus 1/2 plus 1/2, when we add the same thing over and over, that's the same as multiplication. So I can say 1.5 times 3. 1 times 1, we know that's 1. 1.5 times 3, well, I can remember that I can put 3 over 1. What's that going to be? I can rewrite it like this. And then 1 plus 3 times 3 is 9. 2 times 1 is 2. 2 goes into 9. There we go. The difference, or the total amount of rain, 5.5 inches. Our last question asks, what was the total rainfall during the 4 months that received the most amount of rain? So now we're looking on the other side of our chart for 4 months. 1, 2, 3, 4. Oh, it's going to be these. So let's look. 1 month had 3.5. 1 month had 4. And 2 months had 4.5. There we go. So when I solve this, I'm going to start by putting together my parts. Are there any of the fractions that I can put together to make a whole? Well, yeah. I have a half and a half. So I'm going to put those two together to make one whole. So I have 3, 7, 11, 15, and then these wholes go together to make 16, and then I have that half left over. 16 and a half. Remember, I can also solve this by saying there's 1 above the 3.5. So for 3.5, there was 1. For 4 inches, there was 1. And for 4.5 inches, there were 2. When you solve that, you're going to end up with 16.5 as well. This is how you interpret or read